In this video, I'll give you a little bit more guidance on the Boolean assignment so that you can get practice with making comparisons of data that is instead of a numerical type data type or a character data type, you can make a comparison of data that is a logical data type. So these Boolean operators and Boolean functions will allow us to have variables that are either true or false. And we're going to start by doing something we've done for all the other in-class assignments. We're going to read in the first 100 SNPs file, and we're going to load Biomart so that we can do a quick Biomart search. And once we have our Biomart search completed, we'll have data for each of the SNPs in the first 100 SNPs file. We can then merge that data with the 23andMe information that we're given on the first 100 SNPs. And we can start to do a more sophisticated type of filter. In the previous homework, you used a numerical filter to only keep rows in the data frame where the minor allele frequency was less than 0.01. In this assignment, we're going to do a Boolean filter. So before we do that, I have some quick examples in the program of what does it mean to have a Boolean variable, to have a true-false variable. So let's run Boolean example 1. And you can see a new variable appears in our environment, L is equal to true, and that's because the equation that we set L equal to, 2 plus 2 equals 4, is true. If we make an equation that's not true, 4 times 20 does not equal 80, we get a value of false. So let's redo our previous homework where we only kept rows that had a minor allele frequency less than 0.01 by having that be our Boolean value. So we're going to set L, this is going to be a logical vector as opposed to a single variable, equal to a comparison that we make. And one thing we're able to do with logical vectors is we're able to make the comparison of two different statements. So we can first test, does the minor allele frequency value, is that numerical value less than 0.01? And we can also test, and is that value a number? So if we run that, we'll only keep rows where the minor allele frequency is a number that's less than 0.01. And when we run that, we can filter the data so we only keep those rows. If you click on the results of filter 1, you'll see the exact same data frame that you produced using the subset function in your last homework assignment. We can write that to a file, and we can look at how to do different types of text comparisons. So what we're really interested in for this assignment is how can we compare a minor allele, which is 1 letter long, to a genotype, which is 2 letters long. They won't be exactly equal to each other, so that's where the grepl function comes in. It allows you to compare a short pattern to a long expression. So the pattern comes first, so that'll be the string that's shorter, and then X will be the longer string that we look for the pattern in. If I run grepl on dog and category, you can see on the console that that's false. I can change that. If I change it to cat or even GOR, I will get true. If I run line 63, the cat jumped over the moon, it's true. But if I changed it to the more common, the cow jumped over the moon, it would be false. So grepl is a comparison. It's just like saying minor allele frequency is less than 0.01, but it's a comparison that you make between two strings instead of a comparison you make between two numbers. So our next thing we want to do is we want to use logical vectors, and we want to make comparisons for our data frame. So let's look at our data frame and first make sure that we know what is the genotype column and what is the minor allele column. So I'm opening up merge data, and I see my genotype column is column 4, and my minor allele column is column 5. Minor allele is going to be our pattern because it's shorter. My genotype is going to be our string that we want to look for the pattern in because it's longer. So I can run this step by step for every single row in the data frame. It would work if I had a really short data frame. So if I want to figure out if the minor allele is in the genotype for row 1, I would use grepl to compare row 1, column 5 with row 1, column 4. I can test it for row 2, row 3, and row 4. You see every time I'm just incrementing the row in both objects. That's okay if we have a data frame that's 4 rows. But in this assignment, we have a data frame that's 100 rows, and the actual data frame, the full 23andMe file, is 960,000 rows. So I obviously can't manually type grepl that many times. What we can do, now that we've defined this logical vector, is we can automate filling the logical vector with a for loop. If we use a for loop, let's see how it works first. And then once we see how it works, we will print out all the results. So I'm just going to look at the minor allele by using the print function. I'll make sure that it prints to the console. And when I run this, I can see that I have a typo because I didn't type merge data. And you can see that it printed just once because I didn't run the whole for loop, and now it printed all 100 rows. So those are all the minor alleles that are in the data frame, and we're able to make a comparison of those minor alleles to the genotype. So I'm going to comment out the print statement, and I'm copying on line 81 exactly what I did on lines 68 through 71. The only difference in the grepl function is the row. Instead of the row being a number that I specify, the row is the letter I. That way, every iteration of this for loop, the row will change. So I'm going to click on the for and click run. And now you see I have a logical vector. If I print that logical vector, you'll see that it is not only true or only false, but it's a variation. You can see that it really is checking each row. And the fourth row, which we know to be true from our previous test, is true. So now we can use that, just like we did for the minor allele frequency, to filter and get a smaller data frame that just has the rows where the logical condition is true. You can look at the filtered data to see that every single one of these genotypes either has the minor allele or the minor allele isn't specified. So that's one way to approach the project. You can write the data to CSV file. It's probably the most sophisticated type of search that you could do, but I think that what's nice about it is it's going to give you a lot to write about in your report. If you only keep the rows where he has the minor allele or the risk allele, then those are things that the 23andMe report will actually have something to say about it. So good luck with Boolean homework. I hope this video helps you get started.